Good day, class. Today, we will study Boolean algebra, which is the mathematical language behind digital techniques. Every decision a robot, computer, or digital device makes is based on Boolean algebra. Digital systems work using only two values. These values are usually written as 1 and 0, or true and false. Boolean algebra helps us describe, analyze, and simplify digital logic. Think of Boolean algebra as a set of rules that help a robot answer yes or no questions. In Boolean algebra, variables can only have two possible values. 1 means true, on or high. 0 means false, off or low. A sensor detecting an obstacle can be 1. A sensor detecting no obstacle can be 0. Variables are usually represented by letters such as A, B, or C. The AND operation results in true only when all inputs are true. If the left sensor detects an obstacle and the right sensor detects an obstacle, then the robot stops. If even one input is false, the result becomes false. The OR operation results in true when at least one input is true. If either the left sensor or the right sensor detects an obstacle, the robot turns. The output becomes false only when all inputs are false. The NOT operation reverses the value. Not true becomes false. Not false becomes true. If the path is not blocked, the robot moves forward. We use Boolean expressions to describe how a digital system behaves. Examples: A and B. A or B, not A. Boolean algebra follows rules, just like regular algebra, but they are simpler. Identity law: an input remains the same when combined with a neutral value. Null law: some inputs force the output regardless of other inputs. Idempotent law: repeating the same condition doesn't change the result. If a robot checks the same sensor twice, the result is still the same. One powerful advantage of Boolean algebra is simplification. Simplification reduces circuit complexity. Fewer logic gates mean faster operation, less power consumption. A simpler decision process allows the robot to react faster. Boolean algebra is used directly in programming. If a condition is true, execute code. If condition is false, skip code. If statements are Boolean decisions. Logical operators like AND, OR, and NOT come directly from Boolean algebra. In robotics, Boolean algebra helps robots decide how to move. Move forward if the path is clear. Turn if an obstacle is detected. Stop if both sensors are triggered. These decisions are all built from simple true and false evaluations. Confusing arithmetic addition with OR. Forgetting that Boolean variables have only two values. Overcomplicating logic instead of simplifying it. Boolean algebra looks intimidating at first, but it becomes easy with practice. Boolean algebra works with only two values. It is the foundation of digital techniques. It controls logic gates, programs, and robot behavior. Simple rules can create intelligent systems. If you were programming a robot to stop only when two sensors detect an obstacle, which Boolean operation would you use, and why? Thank you, and have a nice day.